Okay, welcome to a section on examples for inequality basics. In this set of examples, first thing we're going to do is identify how to graph an inequality if we're given a graph. Again, notice this is on a number line, so you know you have a single variable that we're dealing with. Okay, looking at the first example, there's three things that we want to go through as we try to write this graph. One, identify your boundary. So if we look at this, we can see here clearly that our boundary is -4. So we're going to go ahead and draw attention to our boundary because that's going to decide our solutions are greater than or less than from that point. Next, we need to identify a variable for this. So we can use x, we can use y. These are numbers, maybe we use n. So we're going to use n and we're going to identify our boundary, and I'm going to kind of write them in a form of an inequality. The last bit that we need to address then is the actual inequality. So looking at this piece here, and let me clean this up for us, we notice that we have an open circle, which means that it's going to be a less than or a greater than sign. Now we need to look at which way the solutions are compared to that boundary. And if you look here, the solutions seem to be moving below the boundary. So if we refer to n as our solutions, which are the pink line essentially, right, they should be all of the values below or less than -4. Let's do that again. Look at our boundary, which we have 5 in this second example, b here. Next, identify our variable, which we're going to call n. And now let's identify the inequality. This time it's a included circle, so we're going to have a less than or equal to or greater than or equal to symbol. And again, our solutions are leading to the left, which means that the solutions should be less than or equal to 5, meaning that 5 is a solution this time, whereas in the previous example, A, it was not because it was not included. Our next example then, C, if we look at this, identify your boundary, which looks to be about 1/2. So we're going to go ahead and identify that, and n again will be our variable. This time our solutions are leading to the right and our circle is open, so we know that this is a less than or greater than sign, and the solutions this time are to the right, so they're greater than this value, so I'm going to make this a greater than sign. Okay, and then the final example, again, I'm going to identify my boundary, which is -1. I'm going to identify my variable, and it is an included circle, so it will be less than or equal to or greater than or equal to, and my solutions seem to be trending towards the greater than sign. So solutions greater than or equal to the boundary. Okay, in this next example, what we're going to deal with is solving an inequality. And we're going to do this at a basic level. So our solving is great here because our solving process is that we know for linear functions, which is order of operations to clean it up, and then start solving by reverse order of operations and inverse operation, are the same for every operation that we're consistent with, except one thing, which we'll see in the next section of notes. So let's go ahead and use these then as we've done before. If we're looking at this and kind of lightly right now, thinking of this as an equality and treat it the same for now, is if we're solving for x, we're going to try to do anything that we need to clean up. That's already been taken care of for us. So then we're going to do reverse order of operations, which says addition and subtraction first, then multiplication and division. Really all we have is to add 3 to the other side to make it disappear from the left, turn to 0. And then we drop down our inequality sign and we find out that x is less than 8. Of course, at this point we would graph this. So we'll go ahead and grab a black line and we'll make a nice line here, and then we will put on here our values. So we know we've got 8, so maybe I'll put 0 somewhere here and we'll count by 2s, 2, 4, 6, 8, and we'll throw a 10 on there to keep it going. So our boundary then, if we're graphing, is the point 8. So we're going to identify that, and we can make it an open circle because our inequality is not included, and then our solutions then happen to be less than, because we read from left to right, running the point first, solutions are less than 8. So that means that my solutions then are going to travel to the left. Okay, on our next example, you'll notice it's very similar. We have a less than sign, so let's go ahead and approach this just like we would any linear function. Looking at x, we're going to solve for this. Notice that 2 is being divided by it, so we're going to go ahead and do its inverse and multiply by 2 on both sides. And those will reduce to 1, leaving just an x, which is less than -1 times 2, which is going to be a -2. Again, at this point, we are solved, so we'll draw a number line. Again, dealing with one variable, so we use a number line. And we'll go ahead and mark in, it's a -2, so maybe we'll put 0 here, we'll put 1 here just for reference. Here is a -1, here's a -2. Keep those as equal as possible, -3. And let's go ahead and address this inequality and start to graph. So my boundary is -2. I'm going to go ahead and circle it. It is a less than sign, not an equal to, so it will be open. And then I'm going to read this again as my solutions are, I run into the point, which means less than 2, -2. So that means my solutions are addressing to the left. All right, there's a few examples for you. You should have seen how to do the basics with inequalities. Thanks for watching. We'll see you in class.